Welcome back. This is the last and final video on the idea of alkane nomenclature. You might wonder, well, it's two videos. Is that simple? Well, it's not that simple, but I've given you everything you need in the first video. And second, it's not practically possible to draw every isomer for every compound and name every one. Okay? Just have to get the basic idea and work your way up from there. So here I'm going to demonstrate two different things. Well, the last time I gave you a structure and had you write name. In organic chemistry, typically if you're given a name and have you draw structure, that's a much easier point of view to come from. So let's do that. So 2,4-dimethyl, you usually see a space between the first and the last name. So this is the last name, this is the first name. So this is your substituent. And this is your, I'm just going to call it SUB for substituent, and this is your long continuous chain. Okay, that's how you first understand the problem. Okay, so that means first you draw 6 carbons, 1, 2, 3, 4, 5, and 6. That's your hexane, because 6 carbon is hexane, right? So first you fix your long chain. Now the reason I said given name writing a structure is easy is because you do not have to determine where to number from. Just go pick one side, and so I'm going to pick this side, 1, 2, 3, 4, 5, and 6, and then say 2 and 4. So the second spot, it's dimethyl, means I have two substituents that are same, one in the second spot, one in the fourth spot, and methyl is CH3, right? And ethyl and methyl again in the fourth spot. So basically methyl is CH3, right? This is methyl. Actually, I'm going to put this one so I know where the practice ones are. And this is ethyl. You always attach through your ethyl as one hydrogen shot. This is what gets connected to the long chain. Okay. Similarly, propyl means CH2, CH2, CH3. That's propyl. Butyl, typically you don't really need more than this because chances of you ever running into a substituent that is pentyl is very rare, but I'm going to just give that as anyway. So that's butyl. And what I mean by the wiggly line is that is the long chain and this is the substituent. Okay, don't get it mixed up. Okay, I'm going to give you a pentyl, but the chances of you doing that is very slim to none. So this is pentyl. These are your substituents: methyl, ethyl, propyl, butyl, and pentyl. Okay, so this is, now you can go back and fill it all with hydrogens. Make sure, you know, whatever is, when it's 3 bonds to a carbon, the fourth has to be a hydrogen, at least in an alkane. So that's 2,4-dimethyl hexane. Let's do 4-ethyl 5-methyl octane. Again, the space indicates this is your last name. This whole thing is your first name. I'm just going to call it first name or your substituent, and last name or your long continuous chain. So octane means we got 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. Again, it doesn't matter which side you start numbering. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8. 4-ethyl, so as I said, your ethyl is CH2, CH3. You don't attach with the CH3, you attach through the CH2. That's just the way it is. And then 5-methyl, again, in terms of space, I'm just going to put this upstairs. It doesn't, I mean, upwards, it doesn't matter whether you put it up or down. At least at this point, it doesn't matter. So it's in the 5th position as the methyl. Now let's go complete the remaining because, you know, there's more than one ways to do it. Again, don't think that this is the way to do it. If you can come up with an alternate method, that's fine, but you have to have a basic, and that's your 4-ethyl 5-methyl octane. All right. I want you to practice those two problems on your own. Now let's move and do these two, and then I'll give you a tool practice. This is a line structure. So if you've already done the line structure exercise, again, as with any structure, first you have to figure out what it is your long chain. I guess there's multiple ways to go. One, again, if you're in doubt, put a dot, okay? So 1, 2, 3, 4. You can also start here, 1, 2, 3, 4, or 1, 2. There's more ways, but I don't think I can ever get a 5, so 4 is my maximum. And 4 carbon means it's butane. So that's my last name. Very good. So I already know the last name to my compound, which is butane. And now, which sides do we start numbering from? Well, this carbon has 2 substituents, means on this side, there's only 1 carbon. On this side, there is 2 carbons, right? This is a substituent of the long chain, right? So you don't count that as number of carbons. You just count how many there is on to the left and right side, not up and bottom. Okay, so on this side, this contains 2 substituents. On this side, I contain 1. On this side, I contain 2. So right away, clearly this side wins the race. You don't even have to try this because, you know, on this side of the substituent, this has more substituent, right? If you look, this side also has 1 and 2, but this carbon itself contains 2 substituents. So this side actually has least number of hydrogens. Remember I said in the drawing line structures, if you end up with a situation where you have equal number of carbons on both sides, then you go by the number of hydrogens. I think it always works. In this case, there happen to be 3 hydrogens here, and this side has a lot more. So we start numbering from this side. So it's 1, 2, 3, and 4. So that means you have two methyl groups, right? One line is 1 dot. 1 dot is 1 carbon, right? So 2 methyl groups. So that means we have also a methyl group on the 3rd position. So we say 2 prime. When they're on the same carbon, you say the number and then the number with a prime, comma, 3 hyphen. There's 3 methyl groups, so it's trimethyl butane. That's a little difficult for many of you, I understand. But if you watch it again, you probably know what I'm talking about. And there's 2 more practice problems that I'm going to give you. But before that, I'm going to work this out. Clearly, you know, no, just visually looking at it, there's no way anything can beat this. This is going to be my long chain. I'm going to put my dots here. You should always experiment to find out what is your long chain. But I've already done that hard work. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. 9 carbon is the nonane. So that's my last name. I'm going to write nonane here. Now, which side has more? Well, clearly, if you see this carbon has 2 substituents in itself, right away it wins the race because this side has 2 carbons, this side has a lot more carbons, right? So there's no comparison at all, right? So this side wins the race. So we go 1, 2, 3, 4, 5. See, I think where you may all get stuck eventually is deciding which side to start numbering. Again, if you typically have a carbon with 2 substituents at the starting of a chain, then you see that this side has 2 carbons, that side has almost 6 carbons. So this side loses, this side wins. So whichever side has least number of carbons, that's where you start numbering. And then you have, see, there are 2 dots hanging off of it. So this is an ethyl group, right? Remember I said ethyl group, which is same as CH2, CH3. I'm going a little fast, but I think I'm making sense, so I can go a little faster. So this is ethyl. These 2 are only 1 dot, so methyl. So which do we start with? Well, we start with the ethyl first because E comes, and that's in the 6th spot. So I'm going to leave plenty of space myself. So 6 ethyl hyphen. There's 1 and 2 on the 3rd position and 1 methyl group on the, again, the dot really helps. 1 dot means methyl substituent, 2 dots mean, you know, ethyl and so on, right? So we have 2 in the 3rd, 1 in the 4th, so 3 prime, 4 trimethyl nonane. I can't keep it any simple than this teaching. This is a massive concept. So we might spend more time. And again, The videos are not meant to cover everything. It's supposed to give you the basic outline and most of the important things, but then there's some point we have to do more practice to actually help you do well. And these are the two practice problems which you will do in your checkbook. And that's all I had to say on Alkane nomenclature. We'll probably do some more exercise in class. So stay tuned for videos on Alkene and Alkyne.